Dave MacFarlane. Please give him a good round of applause.
So that all sounded a lot more exciting than it is. So I want to talk to you about distributed bug tracking today, which is a concept that I find really interesting. And I'm going to do it by way of demonstrating a distributed bug tracker I wrote in Go called Bug. But before I get to that, I'm going to have to go over some background on what I mean by distributed bug tracking. What is that? Why do I think it's really cool? Why is it? What are the features? What are the benefits? So what is distributed bug tracking? It's a concept that's been around for maybe 10 years, and it's a way of leveraging distributed version control systems like Git or Mercurial or whatever you want to track issues alongside your code in the same branch. Any way that you do that in a sort of plain text file that can be managed in a system like Git can technically be considered a distributed bug tracker. The only real constraint is that it has to be a database that's in a sort of plain text-ish format, like JSON or XML or plain text in Markdown in my case, so that when there are conflicts, they can be resolved using your standard tools for whatever version control system you're using. One thing I just learned this weekend is in Go, if you include a comment of the form / bug and then your name and then a description, it will automatically get included in your Go docs. So this is an example from the official Go package. In the byte reader, you have known bugs down at the bottom. If you click on that, you get to the source code, where in the source code, there's a comment that Russ Cox put there at some point in the development of Go about this known bug with this issue. So it's sort of the Go equivalent of having to-do or bug comments throughout your code and getting it inserted to the end of your man pages under known bugs. So technically with this definition, anything like just scattering to-do comments could be considered a distributed bug tracker, but for the purpose of tonight, I'm going to talk about ones that have stronger tooling support. The original concept came from a software called Bugs Everywhere, which I always really liked the idea, but it never really took off. It's 10 years old. It has a very small community, but I always liked the ideas of it. So what is the benefit of putting your issues and your code in the same place? They do have a good explanation there. This is an excerpt from their website. Bugs and codes that live on branches are tracked together. When a branch is merged, both code changes and bug changes are merged alongside each other. We no longer have to be confused about whether a bug fix is applied to a development branch but not yet present in the production branch. Means that our bug is fixed. Users can fully modify bug state while offline. That's a huge benefit, unlike with centralized trackers. And when a user checks out your source code, they get the current bug state for free. So that's a lot of words, and I agree with all that. And on top of that, I would add my own sort of list of benefits. By combining source control and issues on the same branch, bug lists are context sensitive. They're offline capable, and it's way faster than doing things online. Even just logging into GitHub is going to take you 5 seconds out of your workflow, but you have to interrupt what you're doing to do it. Well, when you're on the command line, you have tools there. You can just, a thought pops into your head. You can log a bug and go back to what you're doing in less than a second. Well, depending on how fast you type. If you type like Alex. So this makes it a lot easier to pick things up and drop them off. If you know that all you need to do is run a command like bug list or blist if you're using Bugs Everywhere to see what's unresolved on what you're currently working on, and that's going to be up to date. Centralized bug trackers, I think, are great for tracking user problems with release products, but when you're talking about unreleased feature branches where you're trying to keep track of all this thing, but you're not going to put it in Bugzilla or Redmine, whatever you're using, it's sort of ill-suited to that because it doesn't work into your workflow, and these branches aren't even released yet, right? So you don't want users to know, like, oh, on this thing I'm developing on, this doesn't work yet. That doesn't really make any sense. So by being offline and command line based, they're a lot more flexible, and you can do some scripting. I think the best way to illustrate this is with a demo, but before I get to that, I just want to sort of address why I think this concept never really took off. So with other distributed bug tracking software, other than the one that I wrote, there's a bit of vendor lock-in because things are stored in a hidden directory that if you don't even know it's there and you don't have the client installed, you're not going to look at. Hashes are hard to use in a sort of day-to-day function, and in software like Git, you're generally using the symbolic names like master origin. But when you're trying to resolve a bug, you don't want to be like bug close BEF326 or whatever. And if you think of back to what their pitch was, they sort of pitch as a replacement for centralized bug tracking, but I think it's more of a complement in terms of helping programmers not have to remember, sort of offloading that to the computer. And if you use it that way, your entire team doesn't need to be committed. You can just use it yourself. So how do I address these issues? I store bugs in a non-hidden organized directory structure of plain text files, markdown usually. Bug titles are their identifiers instead of hashes, so it's really easy to discover the current bug state. If all you have is ls and cat, well then that's perfectly fine. And I use just unstable identifier numbers just to simplify the command line, and you can identify stable identifiers later if you want. So in terms of a demo, let's see how this works on the screen. I have a bigger font here, which hopefully makes this go a little better. So I have, this is my source code for my thing. There's this issues directory that has a list of open issues. If I do a bug list, from anywhere in my tree, I will get a list of what's still open on this branch. If I switch branches, actually I should demonstrate that you can also in fact create a bug. So, the basic use cases there, and then it shows up in your demo. So if you're, hacking away on something, and then a thought pops into your mind, it takes about 2 seconds to go create the bug, and then go back to hacking on your thing without having to take time out of your workflow to go, go to GitHub issues, go to Bugzilla, go to Revit, go to whatever you're using, and work out what you want to say, which you're only going to do for major things. This just deletes untracked things. If I go to a different branch, so say my current development branch, you see that I get a different list of bugs, or maybe it's just a subset of the same list of bugs. And that's what I mean by it being context sensitive. So as you're working on different things, you don't need to keep track of what was I doing here, what am I doing on this branch. It makes it easier to come into work on a Monday morning and not spend an hour going, what was I doing? And you can switch between projects pretty easily. That extends to going to different projects. So if I go to something else that I'm working on, like my Git implementation, which is poorly thought out, I will get a list of what I need to do for this Git implementation. So it's going to give you a list of what's going on your current branches, on your current branch of whatever you're working for, without having to jump around. And I think that's a really powerful feature. Another sort of cool feature that I added is the ability to import things from different places. So for instance, if I wanted to import but Golang's open issues, I can just do this, and this is going to take a while, so I'll just kill it. But you can see that we got a list of 800 issues imported, which we can now work with well offline. If our internet connection goes, we can still be, what is this bug? Maybe I want a pager there. What is this bug in Go? I can read this perfectly fine and work on it, and I don't need any internet access. One cool thing about this implementation is that if you close something, which pretend I just fixed this problem with GIFs in Go, even though I didn't. it will include this special GitHub syntax to automatically close this issue on GitHub when you push it upstream. So I think that is a really powerful concept, and I find that since I started working on this, it's really improved my productivity as a developer. And if you guys want to try it out, go ahead. But I just really like the concept. I want to, one other thing, if you are working on something like this, and it's on a project that isn't using this, and you want to remove all traces of it, it's really easy to just rewrite things out of history in Git. And since there's a standard commit message, I can now pretend that I can now not pretend. I probably had 2 more commits, but I can now pretend that I was never using this and I just had really good memory all to myself. So that's the demo that I wanted to show, and I hope people got something out of it. I just wanted to have a couple more slides on something that's more Go specific, because right now all I've said is that this tool happens to be written in Go. Well, great. How does that help you? Well, how does that help you as a Go developer? So this is really more about the power of the Go I/O libraries, but by implementing the I/O reader and I/O writer interfaces, which are standard Go interfaces, it makes it really easy to programmatically create things. For instance, this will file a new bug report. You can put code like this on, it's just using the standard format fprintf, which takes an I/O reader, and so you can programmatically make a page that, say, a user can report a bug, and it puts it in your distributed bug tracker. You can do something like this in, say, the recovery of a panic. You could, automatically load or automatically log crashes of exceptions that happen in your HTTP handler with code like this. It's not really well thought out because, this is going to be on your server. But if you have a cron job that commits and pushes that every now and then hey, you have free bug reports of every crash that happens in your response writer, which I think is, a pretty good thing to get. So that's all I have to talk about today. That's the end of my slides. So thanks for your time, and I hope you enjoyed it and learned something. Is there time for questions? Or is anyone? Yes?
Usually on the centralized criteria, we can have some comments and discussions between developers and users and managers, and I kind of don't see how this workflow would fit well for a large team.
You're right. That's one of the reasons I say that it's very useful for a individual, like tracking their progress on a branch. But for things like that, you do want a centralized bug tracker, and that's why I think they are complementary. I mean, you could adopt a convention where, I'm going to add the timestamp of a comment and then add to the description if you want, and there's nothing stopping you from doing that, but that's the type of thing that you want centralized. Yes?
Well, the bug importer actually goes to GitHub and fetches all the issues further there before you put it in.
Yes, if you don't kill it.
You have this for like Redminer.
Yes, we actually use Redmine at work, and I started writing an importer, and then I realized that the Redmine API at work is disabled, so I gave up on it. But in theory, I mean, it's just plain text files that, anything can create something that, follows this directory structure and, makes a description file or whatever other files you want. And, like I said, you could just use cat to see your bugs.
Yeah, but it's really well suited like if you're working on one feature as a sole developer on a branch, and then at the end you kind of purchase it, but you still use the centralized.
That's how I use it.
But you track everything.
Yeah, because my computer has way better memory than I do. I get in the morning and I have no idea what I was doing. So if I just need to do this to remember, then that takes a lot of cognitive load off my mind. Any other questions?
Did you find this slash
To the where?
Are you trying to slash comments?
Oh, no, I only learned about that feature this weekend in Go. So I am not currently doing that, but I may think about that and think about how to. No, not at the moment. Not at the moment. I think I'm out of time. So.
What was the import you did from where?
It was from GitHub's Go repository.
Oh, the issues that are on GitHub.
Yeah, the open issues on GitHub for Golang/Go is what I did. But it could be any repository. So that. Any last questions? All right.